Welcome to my channel. This is a continuation of our trigonometry because we have discussed sine rule and cosine rule. So today we are going to conclude trigonometry, that is bearing and distances. When you talk about bearing and distances, bearing means the direction, while the distance means how far it has gone. For us to do that, there are two ways by which bearing may be given to us. The first way is cardinal points. You will be given the cardinal points. Cardinal points, that is north, east, west, and south. Meaning that in this situation, the direction will be specified. That's the first way by which we will be given the bearing. The second way by which we will be given the bearing is the three-digit form. The three-digit form in which no direction is specified. But the moment we are given a three-digit form, it means we must start from the north pole of that particular starting point. Here we have our four cardinal points. We have the north, the east, the south, and the west. In between north and east, we have angle 90, south and east 90, south and west 90, and north and west 90. There are four ways by which we can move in this particular aspect. Is that we move northeast, northwest, southeast, southwest. For instance, if I say north 70 degrees east, if I want to represent this bearing, it will be drawn this way. This is my north, this is where we have east. That means I'm to move 70 degrees from north towards east. This is my 70 degrees. This is 70 degrees. That's how to represent bearing on cardinal point. Or let's say we have south 55 degrees west. Or what we need is the cardinal point. Here we have the north pole. This is south pole, 55 degrees. You are moving from south towards west. This is 55 degrees. So when we are given a cardinal point, this is the way we are going to represent it. Let's look at this example. The bearing of A from B is south 20 degrees east. You can see that from B is underlined. What that means is that B itself is the starting point. So when I draw my four cardinal points, this point is point B. The direction where we are now moving, we are moving from south towards east. This is south towards east 20 degrees. So this is 20 degrees. It means at this point we have point A. That's how we can easily interpret bearing of cardinal point. In three digits, in this case, the moment starts from north pole in a clockwise direction. Clockwise direction. That is, when you draw your four cardinal points, this is the north pole. You move from this north pole and move in a clockwise direction. Now it depends on the value of the angle given, but that angle must make up to three digits. For instance, let's say we have angle between them is like 30. We write 030 degrees. But when you want to represent it on the diagram, you put angle 30 degrees. For example, bearing of P from Q is 0.50 degrees. When you look at this from Q, don't forget, that means you are starting from Q. This point is point Q. It says 0.50. So we start from the North Pole and move in a clockwise direction. So at this point, we have point P. This is 50 degrees, as you can see. So angle between the line is not represented with 3 digits, unless if the value is more than 2-digit number. So as this one is now, the bearing of P from Q is 0.50 degrees. When you look at these two lines, they are pointing towards the same direction, meaning that the two lines are parallel. From there, we can talk about alternate angle. What that means is that this angle must be 50 degrees. So, when looking at the diagram, it shows we can find the bearing of Q from P also. To find the bearing of Q from P, we start from P, North Pole of P, then we move in a clockwise direction to the line joining them. This is the line joining the 2 points. This is 90. This is also 90, making 180. With this 50, that will be 230. So we can say bearing of Q from P is 230 degrees. That is, the total angle here is 230 degrees. So whenever you want to find the bearing of one point from the another, what you are expected to do is to look at the line joining those 2 points. When you look at the line joining those 2 points, then look at the North Pole of the starting point that you are asked to calculate, trace in clockwise direction to the line joining them. That will give you the bearing that is specified. Now let us look at this. Please, before we continue, we would like you to subscribe to our channel for more of these videos. Thank you. The bearing of x from y, that means our starting point in this case is y, is south 45 degrees west. Find the bearing in 3-digit form. Let us draw it. Sorry. It is advisable you use pencil when you are drawing bearing so as to know the direction. This south 45 degrees west. This is southwest 45 degrees. That's half line between south and west. This is our starting point, which is y. That means x is somewhere here. This is 45 degrees. So as it is, so find the bearing in 3-digit form. Find this bearing you have here, south 45 degrees west in 3 digits. This is it here. So what you actually need is to calculate the angle from the North Pole off to the line joining x and y. This is the line joining x and y. So bearing of x from y now, we start from the North Pole of y and join this line. And according to what we have here now, up to this point is 90, 180. 180 plus 45, that should be 225. So the 3-digit form is 225 degrees. At the same time, we can change from 3-digit to cardinal points. Depends on what they ask us to do. So this is the introduction. Now we move to make examples. How we can apply this to solve problems on bearing in terms of triangle, applying sine rule, applying cosine rule. Now, look at this example. A bird left a tree and traveled 96 kilometers on the bearing of 0.45 degrees. He then traveled south, that is on the south line until it was 96 kilometers from the starting point. How far south did it go? Let's draw the diagram together. Starting with where the thing started from, on a bearing of 45. That doesn't mean that I cannot clean the diagram. It is not properly drawn here. 96 kilometers, bearing of 45. Remember, this one is a 3-digit bearing. You start from the North Pole and measure your 45. That's half of 90 degrees. Here is where the bird is now. 96 kilometers. There is 45 degrees. So from this one, don't forget, this is also 45 degrees. So the bird is presently here. It then traveled south until it was 96 kilometers from the starting point. This is the starting point. Don't forget, the thing goes until it is 96 kilometers from the starting point, meaning that another 96 is like this, 96 kilometers south of this one. This is what we have. So there's still another 4 cardinal points here. This is what we have. The bird is presently here. This is the tree. This is the bird. So let's try to study the diagram together. Don't forget that this 45 and also this line is 96, this is also 96. What that means is that this is an isosceles triangle, and in an isosceles triangle, two base angles are equal. It means this is also 45 degrees. That's really we need to study the diagram. So if this is 45 degrees, then we can calculate the third angle. How do we now find the third angle? Maybe we should label this one point T, B, and P. To calculate angle T now, angle T will now be, let's put it here. Angle T will be 180 minus sum of this one, 45 plus 45. If you do this one, that should be 90 degrees. This angle is 90 degrees. So if this one is 90 degrees, then it means we are dealing with a right angle triangle. And in a right angle triangle, there are two major ways of solving problems on it. It's either use Pythagoras Theorem or use your SOHCAHTOA. Since we have two sides and we are looking for the third one, Pythagoras Theorem would be more appropriate to apply. So, using Pythagoras Theorem, it means this is our, let's call it small t. T squared will now be 96 squared plus 96 squared. So when you do that one, you are going to get 18432. Then your t will just be square root of 18432. So in that case, our t will now be 135.77 kilometers. So that means from point P, the thing has gone 135.77 kilometers due south. That's how to solve problem on bearing. As you can see, the diagram tells us what to use. So we're going to look at another example that's a bit different from this. Now, this is the second example. A boat sails 4 kilometers on a bearing of 038 degrees and then 5 kilometers on a bearing of 067 degrees. How far is the boat from the starting point? Calculate the bearing of the boat from its starting point. Let's see how we can draw the diagram. H is the angle that we need. We assume that this is 38. Okay, let me change it. This is 38 degrees. This angle is 38 degrees. That means this is also 38 degrees. 4 kilometers. And then, meaning that presently the boat is here. And then 5 kilometers on a bearing of 67. Let's assume our 67 goes like this. So, this is 5 kilometers, 67 degrees. So on this we have 23 degrees. So when we add everything together, that will give us 151. Yes, 151 degrees. So from there, this where the boat is, we can now join to the starting point. As you can see, we can label this one as A, B, and C. In that case, the triangle we have, triangle ABC, the two sides are given and the angle between them. That's where we make use of cosine rule. That's where we apply cosine rule. To apply cosine rule, there must be two sides and the angle between them. And this is the situation where we need it. So using cosine rule, it's a cosine rule. This is what B squared equals to A squared plus C squared minus 2AC equals B. So we can now substitute. Our A is our small a, that is 5 squared plus 4 squared minus 2 times 5 times 4 equals 151 degrees. So when you look at this, it's just a matter of summarizing the calculation. You can press your calculator straight, and this one will give us 75.985. So then B is now square root of 75.985. So for us to find that, we need to find the square root out. So from there, B is now equal to 8.72 kilometers. So the boat is 8.72 kilometers from the starting point. Now, the next question on it says, calculate the bearing of the boat from its starting point. This is the boat. This is the starting point. And I told you when you want to find the bearing of one from the other, you are finding the bearing of both from the starting point, as C from A. Let me draw that to make it clearer to us. This is what we have. This is C and this is A. Bearing of C from A, we need this angle. So out of this angle that we need, part of it is 38. We have 38 as part. So we need to calculate this small one, which is angle theta. And to calculate angle theta, the easier method that we can apply is sine rule. So using sine rule, it means 5 over sine theta. This is the angle theta that we are looking for. 5 over sine theta is equal to this B that we got here. That's 8.72 over sine 151 degrees. Then we can cross multiply in this situation. That will be 8.72 sine theta equals to 5 sine 151. Making sine theta the subject, we have 5 sine 151 divided by 8.72. That's 0. We find it out. 2780. Then our theta is 16.14 degrees. That is not the bearing. That one is just the point, the angle between these two lines. So our bearing now will be bearing from the starting point. Let me clean this diagram. Sorry, the board is small, you have to just manage it. Bearing of both from its starting point is, that will be 16 plus, 16.14 plus 38, which is 0.54.14 degrees. That's how to apply sine rule and cosine rule to find the bearing and distance. I hope we have gained a lot from this particular aspect of trigonometry. Please subscribe to our channel for more videos.